Okay, lesson 1.9. So now we learned how to determine significant figures when we make a measurement or when we look at someone else's measurement. Now we need to learn how we treat those measured values when we do calculations. Okay, and then there's one objective here. We want you to be able to round your calculated values. That means the answers you get with your calculator to the correct place based on the measurements that you used in the calculation.
And you want to read chapter 2.4 starting on pages 41 to 44.
Let's get to it.
So a big thing that we have to overcome as a science teacher is a lot of kids don't understand as to why does it matter about these stupid significant figures when it comes to measuring. And the best thing I can say is remember there's this uncertainty. And every instrument or every measuring tool has a different level of uncertainty. So what I did this year, or I should say last year, is that I took a graduated cylinder, which I'll show you in class. I filled it up to a certain level. We know that graduated cylinder is reading at about 7.75 milliliters. And we know that this one is reading at about, I don't know,
1800 milliliters.
1800 milliliters? Okay.
No decimal point.
1800 milliliters. So this one has 2 sig figs. This one has 3 sig figs. Well, that's interesting so far. And then I poured these two together, and in this last beaker, you can see them added together. And I'm looking at that, and I'm saying, still looks like 1800 milliliters to me.
Me too.
You don't see a visible change really at all. And right there's kind of your answer is why sig figs matter. Because if I add a small amount to a very imprecise thing, we're not going to be able to tell the difference. But if I add a few drops to this precise thing, I can measure that difference. So that's where it kind of comes as an important factor. So let's actually look how we deal with this and what comes out of this notion of uncertainty. So we're going to start off with the addition and subtraction. Since I did the addition of water, it's only fair that I talk about it here. The rule for this is the reported answer when adding and subtracted measurements must not have any digit beyond that of the last digit in the least certain addend. That's a lot of words, which basically...
For a pretty simple concept.
Basically, it's saying you have to stop at the least precise measuring point. And that's something you're going to have to get used to looking at. So if I look at this first example right here, this top measure can measure to the hundredths place. The bottom number can also measure to the hundredths place. So their uncertain digit is at the same place.
Easy peasy.
So when I add them together, or subtract them, thank you, it becomes 1.3 milliliters. Don't forget to add your unit. And since they both stop at the same place, I have to round to that place. But on this next one here, this first top one measures to the hundredths. Hundredths, as in decimal place.
I don't want to step on your toes, but I think that's the 10th place.
That's the 10th place, shush. It is the 10th place. Whereas this one here, which was I was thinking ahead, is the hundreds place, as it only measures to the hundreds place because these two zeros are not significant because there's not a decimal point right there. So that means when I do the math, I will get 1450.2 liters, but I have to round it to the least certain place, and I usually do that by dropping down this line between the two, so you can see that I have to round to this place right here. So my final answer, 1500 liters. You cannot add a decimal. If you add a decimal, you will have too many sig figs and too much certainty.
Okay, so this is where students say, wait a minute. In math class, when we add that up, it's 1450.2. But in math class, we deal with what kind of numbers? Perfect numbers. These are measurements, and Mr. Hunter just very eloquently explained we have to stop where the
most uncertainty.
Measurements we're working with, which one's got the most uncertainty.
So you can imagine that we are dumping these two together into something that has very poor gradations, and therefore we can only measure it to that certainty level. Can we do the last one?
Okay, so see, I hate following that. You did such a nice job with it. But looking at this one is certain, all the way out here to the, what is it, tenths, hundreds, thousands, 10,000s, hundreds, to the
1
millionth place, okay? Where this one, now these zeros are shown, and there's a decimal point, and they're ending zeros that are shown, so this one, these two are part of the measurement.
Yep.
So tenths, hundreds, thousands, 10,000ths. So our least certain point is the 10,000ths place, so again, we kind of,
You have it.
this one, okay, we draw, so that's where our measurement's gonna stop. Now, we can look across that line for our rounding, but we can't include any digits in the answer. So that's 1, 0, 1,
1, 5,
and
1.
then there's 5, 1 grams there. So since that's a 5, our final answer is gonna be 0, 1, 0, 2 grams. That's the right answer in
Yep.
chemistry, and this is the right answer in chemistry because we had to stop at the first point of uncertainty.
Yes, and this is the one that would give you the most trouble throughout the year.
Fortunately, we actually add less often than we multiply and
Yeah,
divide.
so that's a good point. So let's go on to the next type of significant figure calculation.
So we have a slightly different rule for when we're multiplying and dividing with measurements. And again, we have to keep in mind that when we are working with measurements is when this applies. Okay, so the rule is the reported answer when multiplying or dividing measurements should contain the same number of digits as the measurement with the fewest significant digits. So you just count the significant digits and then you round your answer to whatever one has the lowest number. So here we are doing a density problem in the first example. So we have 15 grams, that's a measurement, divided by 1 milliliters to get the density in grams per milliliter. 15 has two significant figures, 1 has 1. 1 is smaller than 2, so 15 divided by 1, again, everybody says, well, the answer is 15 grams per milliliter. Again, the units maintained through it, but because of the uncertainty in 1, if you write 1 with no decimal point and no zeros after it, then you weren't even really sure it was 1.
Yep.
So that means we have to round the answer to one significant figure, which means we're going to round that to 20 grams per milliliter.
No decimal.
No decimal. So that is the right answer in chemistry. And again, that baffles students sometimes but you have to keep telling yourself, these are uncertain measurements, not perfect numbers.
Yep. And
we have to reflect that in our answer. Okay, so the next one, I think we're going to need a little calculator. We're going to multiply that's 2,000, 2.110 centimeters times 3.1 centimeters times 0.0150 centimeters. Okay, so you just go ahead and enter them in the calculator, and the answer comes out 0.0098115. Question is, can we keep all those digits? Well, we have 4 significant figures in this one, 2, and the 1, the 5, and the 0, 3. 2 is the smallest, so our correct answer is 0.098. We're going to let it in 8 because the next digit was a 1. The unit is cubic centimeters, because centimeters times centimeters times centimeters is cubic centimeters.
you have to make sure your units stick around, and you have to do what the units tell you. So over here, we divided by grams by milliliters. So your unit is grams divided by milliliters. Here, centimeters times centimeters times centimeters. Well, that's either centimeter times centimeter times centimeter, or if you're at all, fluent in math, cubic centimeters. Okay?
All right, so here's your post-video questions. We've got 2 addition and subtraction questions and a division question. Determine the proper answer using the proper significant figures in units. So again, we know that you know how to add, subtract, multiply, and divide. What we want to know is, do you know how to apply the rules for significant figures when you're adding and subtracting or multiplying and dividing with measurements?
I want to make one quick note. That is not a 5. I apologize. It's hard to write on this. That is an S. It is meters divided by seconds.
Okay.
All right.
So have at those. Bring the answers to class tomorrow with you.
Have a
See
good
ya.
one.